Okay guys, one application problem and one implicit differentiation problem. Their favorite application problem is this: maximizing the plot of farmland given a certain amount of fencing. So they say there's a plot of farmland with a river on one side. You have 2,300 meters of wire. Maximize the area and then give the dimensions. So here's my picture. I have a river, that's my river, two widths and a length. It doesn't matter what you call them, just come up with a formula where you have two of this side and one of this side. Now we know the perimeter, if we add it all together, equals 2,300. So we have 2,300 equals 2W plus L. And our area is W times L, right? So we have two equations. We're trying to maximize area. So we are eventually going to take the derivative of this function here. But we can't do it in terms of two different variables. So what we do is we use this top function to solve for one of the variables and then plug it into our area function so it's in terms of only one variable. So what I've done is I've solved the perimeter for L, and then I plug this value for L into my area function. So my area is W times, instead of L, 2,300 minus 2W. Here's my area function. Now I need to take the derivative of this function and see where it equals 0, because remember that's our maxes and our mins, right? So I take the derivative, I solve for W. W is 575. Once I find out what W is, I plug it back in up here in my perimeter to figure out that L is 1,150. Then I multiply them to get my area. Okay, one quick implicit differentiation problem is find the equation of a tangent line at the given point on the curve. We have x squared y squared equals 100 at the point 5, 2. So I implicitly differentiate. I first take the derivative with respect to x, so it's 2x y squared dx. Remember, this goes to 1. And then I have 2, I'm taking the derivative of y now, 2y x squared dy dx. I solve for dy dx because this is the slope of my tangent line. Be very careful rearranging and simplifying, but dy dx, after you rearrange and simplify, just becomes negative y over x. So I plug in negative y over x to figure out what my slope is. It's negative 2/5. I go back to my favorite point slope form of my line. So I get y minus y1, which is 2, equals negative 2/5 x minus x1, which is 5. I distribute and I rearrange, and y equals negative 2/5 x plus 4. Okay guys, I have one more implicit differentiation problem and one related rates problem, and that's it for test 3.